Let us discuss miscellaneous of chapter 1. Question 1. A, B, C and D. 4 sets are given. A is x such that x belongs to R, x square minus 8x plus 12 is equal to 0. And B, C and D are already given in roster form. So we have to tell that among these set, which sets are subsets of one another. So what we do, we will first write A also in roster form. So x square minus 8x plus 12. What will be the factor? X square minus 6x minus 2x plus 12 is equal to 0. So we will find x minus 6 minus 2, x minus 6 is equal to 0. X will be 2 comma 6. So we will write A as 2 comma 6. Now we will check which sets are subset of other sets. So let us start with A. A is 2 comma 6. Now 2 comma 6 is subset of B. 2 comma 6 is subset of C, but 2 comma 6 is not a subset of D because 2 is not there. Now let us check for B. B is subset of C, right, because 2, 4, 6 are there in C, but B is not a subset of any other set here. Now C is the bigger set, so it is not a subset of any set, but D is a subset of all because 6 is there in all the sets. So D is a subset of A, D is a subset of B, and D is a subset of C as well. Question number 2. If x belongs to A and A belongs to B, then x belongs to B. So we have to say whether it is true or false. If it is false, we need to give the examples. So this statement is false. Let us check with the help of example. Here x belongs to A. So I have taken set A as 1 comma 2 and B as 1 comma. So this element, this set A should be an element of B. That is why we have written it in this form, 1 comma 2 comma 5. Now this x I have taken as 2 because 2 belongs to A and this A is belonging to B. But we can see that 2 is not belonging to B. 2 is not an element of B. This is entire, this is one element for B. So we cannot break it and write 2 belongs to B. So this is entire element 1 comma 2 belongs to B, but 2 is not there in B. So this statement is false. Now second is, if A contain in B and B belongs to C, then A belongs to C. This is also false. Let us check how. We will consider these sets. A is equal to 2, B is equal to 0 comma 2 and C is 1 comma 0 2 comma 3. As B is an element of C, so I should write B in this form here in C. Now we can see that A containing in B and B belongs to C, but A does not belongs to C. 2 is not there in C. This is entire set 0 comma 2 is there, but only 2 is not there. So we will write it is false. Then third is, if A contain in B and B contain in C, then A contain in C. That is true. We can see with the help of this diagram, because if it is true, we don't need to give the example. So I have just drawn this example to this Venn diagram to explain you. A is there in B and B is there in C. So obviously A is there in C. So A is contained in C. Now if A doesn't contain in B and B doesn't contain in C, then A also doesn't contain in C. Yes, this is false. Let us check how. Here we can see that A does not contain in B. A is 2, 3 and B is 0, 4, 5. A is not containing in B and B is also not containing in C. But A is containing in C. We can see that 2, 3 is there in C. So this statement is false. It doesn't mean that A also should not contain in C. Now fifth one is, if x belongs to A and A contain in B, then x belongs to B. So we will write, this is also false. We will take the examples. A is 1, 3, 5, B is 1, 4, 6. Now 3 belongs to A and A doesn't contain in B. Right? A is not containing in B. All the elements of A are not there in B. But 3 also doesn't belong to B. So they were saying that x belongs to A and A doesn't contain in B, then x belongs to B. Here 3 belongs to A doesn't contain in B, but 3 also doesn't belong to B. So the statement is false. Now sixth one is, if A contain in B and x belongs to B, then x doesn't belong to A. So this is true. How? Because we can see that A contain in B here. You can see A contain in B, and they are saying X doesn't belong to B. Now if X doesn't belong to B, it means X is not there anywhere here. So if X is not there anywhere here, it means X is outside. If X doesn't belong to B, it means X is outside. So if it is outside, it means it doesn't belong to A as well. So these are the examples for false statement that you should remember and write true or false accordingly. Now question number 3. Let A, B and C be the set such that A union B is equal to A union C. So this is given to us and this is given to us. A intersection B is equal to A intersection C. We have to show that B is equal to C. Now to show B is equal to C, we have one method which we use always. We have to show B contain in C and C contain in B. If I will show this, it means B is equal to C. If I will show that these are containing in one another, then it means B is equal to C. Now see, to show B contain in C, what we do? We consider let X belongs to B. I will consider any arbitrary element X which belongs to B, and I will show that to show X belongs to C. If I will show that this X belonging to B is also belongs to C, then it means they are containing, this B is containing in C. So this is the method to show if one set contain in another set. What we do, we will consider an element from this set and we will show that this element also contain in this set. With the help of Venn diagram, I will show you, like this is B. Now suppose X is containing in B. Now if I will say that X contain in C as well, C should be outside, then only X contain in C, because X can be here on the boundary also. If I will take inside, so X can be outside C as well. So if I will prove that this X belongs to B implies X belongs to C as well, it means B is contained in C. So this is the method to show one set contain in another set. Now X belongs to B. If X belongs to B, then X belongs to A union B also, because A union B, in A union B we should take all the elements of A and B. Now X belongs to A union B. Now A union B is equal to A union C. So it means X belongs to A union C as well. What does it mean? It means X belongs to A or X belongs to C. So with this part it is done, because I have to show that X belongs to C. So this part it is done. Now I will deal with this part. Now X belongs to A. Now here X belongs to B and X belongs to A. What does it mean? This implies X belongs to A intersection B, as X belongs to B as well. In the beginning we have considered that X belongs to B. Now X belongs to A intersection B. So if X belongs to A intersection B, it means X belongs to A intersection C as well, because A intersection B is equal to A intersection C. So this implies X belongs to A and X belongs to C. So and means they are there in both. So with this also we are getting that X belongs to C. So X belongs to B implies X belongs to C. X belongs to C. What does it mean? B is containing in C. Similarly, we have to show this. Let Y belongs to C to show Y belongs to B. We can take X as well here, but I am just taking another element. Y belongs to C. Now Y belongs to C, what does it mean? Y belongs to A union C, because in A union C we have all the elements of A as well as C. Now Y is an element of C, so it should be there in A union C. Now A union C is equal to A union B, so it means Y belongs to A union B. What does it mean? Y belongs to A or Y belongs to B. So this part is done for this or. Now we have to deal with this. Now Y belongs to C and Y belongs to A. What does it mean? Y belongs to A intersection C, because Y is there, because Y belongs to C and Y belongs to A. So it means if it is belonging to both, so it should belong to its intersection as well. This implies Y belongs to A intersection B, because A intersection B is equal to A intersection C. So in place of A intersection C, I can write A intersection B. So what does it mean? y belongs to A and y belongs to B. It means y is there in both. So we have done with this part as well. We started with y belongs to A and we reached at y belongs to B. So y belongs to C implies y belongs to B. So what does it mean? C containing in B. Now B contain in C and C contain in B. What does it mean? It means that B is equal to C.